Hey all, today we're going to do a little bit of review from last time and then talk about samples a little bit more, some about the biases that can occur with samples and how random sampling can kind of prevent some of that by picking methods that really avoid some of the biases that can pop up. So to start out, what we're going to do is look at your Day 2 class, and hopefully you have that in front of you. The entire front page, if you notice, is review on questions dealing with sample population and then interpreting tables. So all the way through number 10, okay, that's all review. So actually what I'm going to have you do is at this time, pause the video and take a stab at all of those problems 1 through 10. I will walk you through some of the ones that are a little bit more challenging and make sure we're really clear on some of those important details. Okay, but I recommend grabbing out your practice if you need it from last time, but then just pausing the video and taking a stab at those. Okay, I'm going to go a few problems at a time, show you the answers. Okay, so make sure that you have a good attempt on all of them before pressing play again. Right, the first two problems we're talking about population and samples. Remember, population is the whole group that you're looking at, and the sample is a subset of the group if you're dealing with a sample in general. Then we're talking about variables being categorical or numerical. The variable is whatever you're asking the question about or classifying, and that can look like a category, a specific group, or numerical, we answer the question with a number. So the first one, the population, was all of U.S. households, and this one was the whole population because it was looking at every single household. The U.S. Census does a census every 10 years. Remember, the word census means you are calculating the information on everyone in the population instead of looking at a sample. Okay, so population, and then it asked about the variable. So it was reporting the number of households, so we've got a numerical variable. Now, remember when we talked about different levels of income, if you have a table where those are grouped together and specifically goes from this value to this value, that would be categorical. Okay, so just remember, sometimes intervals, even though they look like numbers, really aren't. Okay, this one's specifically talking about the number of households. Next one was paint on every 15th car produced at a plant. Okay, we're looking at the population for all cars at the plant. Okay, we don't want all cars in the world because when you're producing these cars, we can't say the quality here is the same quality as a different plant. So be specific, all cars at this particular plant. Now, I told you that you can look for specific words to indicate samples. Every 15th car tells us that this is not looking at all of them. Red flag right there that this is a sample. And what we're doing is deciding how well they are painted. So it's excellent, acceptable, unsatisfactory. Those are groupings, categorical. Now what we're going to do is talk about the table. So more about variables to start out with. Remember, we look at the row and column headings to decide what the variables are. Here we've got countries going on the rows, and we've got our different fields of study that are going on the columns. It does tell us specifically here, let's just read some information about this table. It says it reports the number of academic post-secondary degrees conferred. That just means finished and officialized, and the percentage distribution of degrees conferred by field of study in various countries. So it breaks us down by those two things we just talked about. And this was conducted in 2004. So we talked about this first one. We want to know, is this trustworthy? Well, we read up here kind of what it was doing, but we didn't really read where it came from. That's one place it may show up. Also look at the bottom. Sometimes the source is there, and it is in this case. It says the source is coming from the U.S. Department of Education. Since we're talking about education, these post-secondary degrees, this is a trustworthy set of data because that's relevant to what's being displayed in the table. Okay, so make sure a source is there, but also make sure it makes sense to what's being represented in the table itself. Now we're going to go answer some questions about the numbers. Let's take a look at some trends and what's going on here. It says, what country conferred the largest percent of its degrees in health? So I want to kind of break down how you look at this table. So these are percents. Anytime your table is representing percents, it is super important to figure out, are these percents by row or are these percents by columns? So let me break down what that means for this one. So is this 9% of all of the people in Denmark were in education, or does it say 9.7% of all of those in education were Denmark? Remember, percent, that word of tells you the total, which means the order here really makes a difference. Now, some of these you can say them out loud and it's going to tell you which one makes sense. Or if we look a little bit more closely at the table, we can figure out the same thing. So one really obvious way that works is we know percents add up to 100. So you can just go through and see, well, does the row or does the column add up to 100? So I'm just going to go this last column here because there's a red flag to me. If you add up all of those numbers in that column, you get over 100%, which means this is not talking about social science being the whole group, it's talking about the countries being the whole group. Now for this one in particular, to me, an obvious indicator of that as well is the fact that it gives you all of these different fields of studies, but it doesn't give you every country in the world. And because it doesn't, we can't break down, well, that's 9% of all education, because we didn't see all education. We didn't see those other countries that offer that as a field of study. Okay, so a couple different ways there. Now that we know that, we can answer this question. It says, what was the largest percent of its degrees in health? So we want to look at health and just look for the largest one. It's already in percents for us, so we don't have to work hard. The largest number there, it looks like 28.6. Denmark it is. We're done. On number 6, we're asked to write a sentence. Remember, we want to include the source and the year, but also tell about that number that's given specifically in regards to the table in context. So look at your row heading, look at your column heading, and think about, is this number exact, approximate, do I need to add on zeros, what's going on? So let's talk about the number 38.5. So we already know it's a percent, so we've got a label there. But we have to think about, is this an exact number or is this an approximate number? Now, for this, it may not be obviously clear yet, but this is the first time we've seen a percent in a table, and I want to give you kind of something to look for again. So with percents, they're not going to tell you that they're rounded, except by showing you they're rounded by looking at the table's values. If you notice, every single thing in this table rounded to 1 decimal place. That doesn't happen in real life. Okay, if we're talking about a set of, here we're talking about degrees, but if we think about any number over another in a ratio, they don't magically turn out to 1 decimal, 2 decimal, 3 decimals, all the same way. Okay, to give you an example of that, if we think about fourths, 1/4 is 0.25, but 2/4 is 0.5. It doesn't end at the same decimal place. So because of that, if they're all represented the same way, that is a red flag if this is rounded. So you'll notice in my sentence here, I have approximately. You have to have that too. Again, you can just use the symbol. Sorry, that got a little wonky. You don't have to write out the word. I'm good with that. I am actually okay if you do want to abbreviate. Some of these sentences get a little bit long. If you want to do department and of ed, that's fine with me. Okay, just I'm looking that your details are there, not necessarily that you spell out every single word. Okay, you can shorten things with common abbreviations. All right, but it says we want to talk about that specifically. So if we look at 38.5, it's right here. and it's the corner of Korea and math and science. But because this is a percent, remember, we have to make sure that after the word of, we're putting our total. We decided that the total was by country, not by the field of study. So this goes after of because it's a total. So order matters. We can't say 38% or 38.5% of math and science were conferred in Korea. That's not true. But we can say that 38.5% of degrees conferred in Korea were in math and science, or the field of math and science. Okay, and so that's how it's written in there. I use conferred because that's what was given in the table information. Sometimes you have to read up there to get specific details, like we did with the civilian non-institutionalized people. Okay, so that kind of gives you an idea of where to look and a reminder of what details I'm looking for in a sentence. Number 7 here, it said, did Denmark or Hungary confer more degrees in math and science, and by how many? Well, this is talking about degrees. It's not talking about percents. Okay, so that's an important detail here. Percents give you a ratio based on the total, and that allows us to compare values more equally, even though our number totals here aren't equal. Okay, so it gives us that ratio, and that's a really important way to compare unlike things is by using percentages. So now we're actually asked to work backwards. Let's look at the plain degrees. So for this one, it wanted us to look at math and science. Okay, so I'm going to erase my markings on this. Okay, we want to look at math and science, and we specifically are comparing Denmark and Hungary. Okay, so Denmark math and science is this number, Hungary math and science is this number. Okay, if we just look at that, 18.3% is larger than 9.5%. Okay, but when we're talking percentages, that's based on the ratio from the whole. Let's take a look at those whole numbers. Over here, the totals are given, and you'll notice that Hungary had a lot more degrees than Denmark did. Okay, almost double. So we can't compare these flatly. Okay, what we want to do is put them back in terms of the number of degrees. To do that, we just have to multiply it. Okay, but in order to do that, we have to multiply by the decimal, not the percent. So remember, always just move that decimal back 2 places. Back 2 places. Okay, so we'll take this times this. So here I put a little d for Denmark, 0.183 times that total, and I rounded to a whole number. It really doesn't matter what you round to at this point, but we are talking about degrees conferred. So this is talking basically like how many graduates did you have in that field of study. You can't have a partial graduate, so I rounded to a whole number. You can wait until the end to round, that is also fine. Then did the same thing for Hungary, and remember 2 places, don't forget to tuck that 0 there, multiplied it by its total number, and we got 6902 there. It does say how many more degrees. We see that Denmark is the larger value there, even okay, our percent was larger, and we ended up having more degrees as well. And then we want to subtract them, okay, to get the difference between how many degrees that actually was. Just a couple more questions here. It says, what field of study was the largest number of degrees altogether? This could be a difficult problem. Okay, I say it could be because when we're talking about the number of degrees, that becomes a situation where we have to multiply the percent by the value again. But sometimes it's obvious, and in this case it was. If you look at social sciences, they have a large percentage in every single country being in social science. So Denmark, the biggest is in health actually, but not by a whole lot. In Hungary, biggest is in social science. In Japan, biggest is in social science. In Korea, math and science wins out a little bit. United States, social science. Okay, so it's overwhelming that social science does more than the other fields of studies. We don't actually have to do the math for that. In order to do the math for that, we would have to multiply each of these cells to analyze the total in the different fields, and it wouldn't be a lot of fun. We do have to do a little bit of that in number 9, okay? I want to talk about number 9 in more detail because it is a little bit of a challenge as compared to some of the other problems that you've had to do with analyzing tables, okay? But I want you to remind yourself of the word of, okay? When you're dealing with percents, of tells you what goes on the bottom. So it says we want all degrees in education. We just talked about degrees here. We had to multiply by something. In this case, it wants every single one that's in education. Well, that requires a little bit of work for us because education here is based on percentages. And we can't add up all those percentages because remember, education will not tally to 100%. Okay, instead, what we have to do is take each of these and multiply them separately, then we can add them. So on the denominator here, you've got each of those percents written as a decimal multiplied by the total they correspond with, okay, all along the bottom, and then we add them together. If you need to pause the video to do that because it was a tricky problem, feel free to do so. Then on the top it says, were conferred by the United States. Well, we're in this education column, but we only want to look at the United States. That's this 13.2. So that last little thing goes on top as well, and you can calculate the percent. Now, I want to talk about the percent. Again, it's approximate because all of these are, every single one, even if we didn't have to round, which we did. We have to make sure that we are writing approximate because they were rounded. And then because they rounded to tenths in the table, we need to round to tenths as well. Okay, I told you if a percent is represented in the table, you want to round to the same thing. Okay, that table gives you knowledge even if I don't directly tell you what to round to. Okay, so pay attention to that. The last problem here is interpreting. Remember, we want all the details, source, years, and what's going on. Now it says, according to U.S. Department of Education, there's my source, there were 646,983 degrees conferred in Japan in 2004. You'll notice I did not include about, because here in this table there are no decimals involved, okay, which means rounding isn't happening obviously, and there's no information that tells me this is in hundreds and thousands or rounded. So this is actually an exact value. And another thing that tells you that is when the U.S. Department of Education is listing those conferred, they got that information from the college. That's an exact value. Okay. Now that we've reviewed all that stuff, we're going to get on to the new stuff. It's actually not a whole lot. It looks like a lot on your paper when you flip over, but a lot of what is on your paper are just definitions. Okay, so we're starting out talking about sample methods and sample biases. When you take a sample to get data, you're not looking at every single person in the population, which means there is some room for error. Okay? Now, there is a good thing about samples, though. It saves time and money. You don't have to go ask every single person. Okay? It preserves the units being studied. Okay, I've been talking about the population as people, but it doesn't necessarily have to be. Okay? If we want to sample, like I said, sample some soup, if I take a spoonful of soup to taste it, well, that soup's gone now. It ruins whatever I was trying to taste. So if I tasted the whole pot, there would be nothing left, okay? So it preserves the units that you're studying. But it can also give more information than a brief survey of an entire population. When you're only looking at a small group, you can get more informed information than trying to spread your resources out to the entire population, and then not having the time to weed out false information or biased information. Okay? Now let's talk about biases. There are two branches of biases. So the first one is how the sample is selected. Okay, so these are size bias, convenience bias, volunteer response bias, and judgment bias. Okay, so let's go through what these look like. The first one is size bias. This actually shows up if your sample is too small. or if size plays a role in how they're being selected. Okay, so let's go through those. If a sample is too small, say I wanted to sample the whole school, Hays High, or I wanted to get information on all of Hays High. If I only chose 2 students from Hays High for my sample, that wouldn't be very representative. Okay, I'm going to get a 9th grader and maybe an 11th grader. I missed 2 big groups. I could get 2 athletes, and then I missed all of the people who aren't involved in activities or involved in band or other extracurriculars. Okay, so not representative because it's too small. The other option is if size plays a role in how you're selected. So say I'm picking names out of a hat. If you've ever gone to like a mall where they're having a drawing, okay, if the slips of paper aren't the same size, you're going to go pick the biggest size of paper so that they are more likely to draw your name versus someone else's. Okay, so if size plays a role in how it's selected, that could be size bias. The next step is convenience bias. Okay, so we're talking about wanting to learn about Hays High again. If I just conveniently grab the 50 first people who walk in front of me, that's probably not very representative of Hays High because I only see Hays High math students who are my students. That's not representative of everyone in Hays High. Okay. The next one, volunteer response bias. This one is pretty self-explanatory. Okay, a lot of times when you're doing opinion surveys, so a company wants to know how they're doing in terms of your satisfaction. The people who respond to those kind of surveys are either very pleased with their service or very not pleased. So when it's a volunteer response, okay, opinions, I missed something there. Will skew the data because, like I said, it's going to be one end of the spectrum or the other, and you don't really get to know about all the people who are in the middle. The last one is sometimes the hardest to determine, judgment bias. Judgment bias is based on the sampler. So if there is a bias in who is choosing the sample, so if I am the person going to select the people, I may go choose someone different than a random sample would, and it may not be representative. Okay, so judgment is who is the sampler, and who they pick may cause lack of representation. The second branch of biases is how the responses are reported. Okay, and this is really prevalent in surveys. So one is non-response bias. So if you send out a survey and you're letting everybody be your sample that you send this survey to, some people may not respond, and that leaves out some important information. Questionnaire bias, if questions are worded one way or the other, that kind of lead you into the answer you're supposed to answer based on what data they want to collect, that causes a bias. And then there's also bias from incorrect responses or measurements. So people can falsely report what they said. I remember talking to you last time about those people who were wearing protective gear. They could have said they wore helmets but really don't. Sometimes when the data being collected is about the person, sometimes they're less likely to respond if it's an answer that may be frowned upon. Measurements also, if you're talking about height or something, it could be measured in different ways, different scales, so may not be as accurate as when they're reported differently. Okay, so those are the basic types, and what we're going to do is go through some examples to make these a little bit more clear. So the first branch, remember, is size bias, convenience, volunteer response, and judgment bias. And we got a couple examples to kind of walk through these. So first up, it says you want to estimate the average number of TV sets per household in your community. So we want to look at what's the population and what might be better about sampling versus conducting a census. Remember, that just means getting everybody in the population instead of just a subset. So our population here is like, who are we looking at? Who are we collecting data on? And it's talking about the households in your community. So your population is your community. Okay, you do want to be specific on that in terms of saying it's households, only because we don't want to think about TVs that may be in like a business. Okay, specifically talking about households in your community. And then what are the advantages of sampling? So why would it not be a good idea or not be as fun to go to every household in your community? Okay, so let's think about Hays. Think about the number of households here. I would say an advantage of sampling is we could probably pick a subgroup that's representative without having to go to every single household. Okay, so biggest thing, it saves time and resources. Think about all the people you would have to employ to go survey those people and collect that data for you. Now, a lot of people have been doing polls online versus door-to-door in terms of like the census even this year was mailed out, but you could return it online, which was nice. So technology has increased the ability to do more widespread surveying, but that also has some drawbacks in terms of the non-response. Let's look at the second example here. It says, describe the type of sample selection bias that would result from each of these sampling methods. So you've got the ones up there above: size bias, convenience bias, volunteer response bias, and judgment bias. Okay, size, either the sample's too small or the sample size is, or what you're sampling size would affect it. Convenience, you just grab the ones closest to you, and that's problematic. Volunteer response, you ask specifically for people to answer, and usually opinions make that bad. Judgment bias, you have a specific person who is choosing your sample, and that may not be great. So what I want you to do is read through A, B, and C and decide which bias is present. Pause the video and get that done for me. First up here, size bias. It's not that the sample is too small. It doesn't tell us how many are selected here. But if we think about longitude and latitude as specific coordinate, and we're only choosing the farms at this, if your farm is huge, you're going to take up more coordinates, which means you're more likely to be chosen. Which makes it biased, because we want to make sure that when we're picking our samples, each person in the population is equally likely to be chosen. In this case, each farm in the population is equally likely to be chosen. The second one, okay, the professor is choosing these people. Now, don't get me wrong, he said he's trying to choose the most diverse communities, so making sure it's trying to be representative of, you know, all these valedictorians in Illinois, but he's still choosing them. And so this is a judgment bias. It's always better to choose your participants randomly instead of specifically selecting them. Next up, it says percentage of students with the AP exam, okay, but it's teachers on our list are reporting them. Okay, anytime it's self-reporting, okay, that is your volunteer response. Now, this is not necessarily one where an opinion would be a problem. It's maybe they would fudge their results to make them look better because they don't want to respond with the ones that make them look bad, or they would forget to respond. Okay, it could be a little bit of that non-response bias as well. Okay, but specifically we're talking about the way it's selected, so this is a volunteer response bias. Let me add that word on there, sorry. Alright, let's look at the next example with that next branch here. Okay, this one specifically we're going to talk about questionnaire bias because I didn't go into a lot of detail like that, but it's questions that are written in a way that leads you to one answer versus another. Okay, it's not really going to give you some representative results. We want to make sure that we're writing questions as unbiased as possible or as fairly as possible. So we're supposed to look at these pair of questions related to gun control. And before I even read the question, I'm going to go look at A and B. It says, should people who want to buy guns have to pass a background check to make sure they have not been convicted of a violent crime? The next one is, should the government interfere with an individual's constitutional right to buy a gun for self-defense? So those kind of are the different sides of the fence there, and they're both worded to kind of gear people towards their point of view. Okay, this one says convicted of a violent crime. It kind of encourages fear there. This one is interfering with individuals' constitutional right. Okay, all of these things are worded to try to get you to answer the way that the surveyor wants you to answer. So our job is to decide which question is more likely to show a higher percentage of people who favor gun control. So which one's going to make people want to put some control on gun ownership? Well, that's probably the one that is saying that gun owners can't be those who convicted violent crimes, because this one is supporting people's right to have guns. So they can be worded in two different ways. I kind of want to show you an example of that on paper to see how things can be manipulated to lead people to a particular answer. Big issue with questionnaires. You got to watch out for that. Generally, more is less. A more fair question is, do you favor gun ownership control? Very short, to the point, doesn't add in extra words that kind of lead you one way or the other. Now, all of those biases that we're talking about can be controlled somewhat by random sampling. Okay, I kept saying that word. We want to pick these randomly. There are different ways to do this. So here are some methods, and these are by far not the only ways to sample, and these are the most basic ways to sample. Okay, so they're not in-depth, but they are ways that are commonly used. First up is simple random sample. This is where all possible samples of a given fixed size are equally likely. Okay, so when we're talking about those farms, they weren't the same size. That's the problem. So they weren't equally likely, because they were looking at the coordinates. Well, instead, we can start with a list of all units in the population, and they call that the sampling frame, number them, and then use a random number generator. We have those on our calculator to choose units from the numbered list one at a time until you have as many as you need. So say you want 50 in your sample, you would pick a random number 50 times, go choose them. So instead of picking coordinates for the farms, you could have just numbered all the farms, 1 through however many there are, used the random number generator and chose them that way, and that would have been more fair. A stratified random sample is an SRS, so it's still a simple random sample, but before you number them, you first divide the group into subgroups that are called strata. That's why it's called stratified random sample. Okay, so these have to be non-overlapping subgroups, and when you're talking about stratifying, they share characteristics. So we're going to group people and then choose some from each group. The next one is a cluster sample, and it's still a simple random sample, but it's a non-overlapping clusters of units. So the reason I said subgroups and clusters, I kind of define that, is because these seem very similar. Okay, but if you read the steps, they're slightly different. Okay, so the first one is you're creating a number list of all the clusters. Okay, so you're going to group clusters, and then instead of taking a piece of each group, you're going to take a simple random sample of your groups, your clusters, and then you're going to obtain the data on all the units in your cluster. So let me kind of overview this again. We're still grouping things, but not necessarily those who share characteristics. Sometimes this is done conveniently by like location. And then instead of grabbing a few from each group, you're going to pick a few random groups, but then choose them all. Okay, this is more convenient. Now, sometimes more convenient is not necessarily better in terms of more representative. So you do have to be careful with cluster samples that each of your clusters does represent the whole population. So with this sampling method, there's an extra step to make sure that it is representative. The last one, systematic sampling with a random start. So systematic sampling in general is not necessarily a way to eliminate bias, but if we include a random start, it is. So this is where you methodically select units starting from a randomly chosen unit. So we're going to still do a SRS from the population. Okay, you're going to take a simple random sample. That gives you a random start. And then you pick every X after that. So maybe every 10th person after that, every 20th, depends on how many units you need for your sample, and then you can divide your population to decide what number that needs to be. Okay, but it's really important that we start from a random person, because if we start with 1 and then go every 10th, or we start at 1 and go every 5th, that means 2 and 3 aren't as likely to get chosen. So it's really important that we start at a random spot. So, for people who like visuals, I really like this, especially for the difference between these two. Here's how it works. Simple random sampling, you take the whole group and you randomly choose people throughout. You could have two next to each other, but usually they're spread about. Stratified random sampling, you first separate them into groups, specifically groups that share characteristics. Okay, so to give you kind of an example of this, you could, in Hayes High, stratify by grade level. 9th graders, 10th graders, they share characteristics because they usually attend the same types of classes. Okay. Then you randomly choose some from each. The difference with cluster, you still separate them into groups, but usually those groups are more convenient, like location, so like classroom in here, and then you choose entire groups from there. Again, this is not necessarily representative. You do have to be careful with things like this. If at Hayes High I were to separate by groups and then choose random groups, well, I'm going to get all math students or all English students, and then it may not be representative. So a cluster sample where we choose classrooms would probably not be ideal. Then last one, systematic with a random start. Okay, it looks like they started here, and if you notice the arrows, it goes this way, so they're going 1, 2, 3, 4, 5, every 5 after that, every 5 after that, every 5 after that, and so on. Okay, so again, sometimes you get ones next to each other in terms of below, but that's kind of what it looks like there in terms of all of the 4 different sampling methods. So how we decide if we know what we're doing is, what if you had to create a survey for all of those? Okay, this one, it says you're given the task to estimate the average number of hours per week spent studying by students in your school. So it is Hayes High as our population. And we're supposed to see how could this look for a simple random sample, a stratified random sample, cluster, and systematic, and then which would you choose and why. So what I want you to do is think about this. Okay, we're going to do each of these and how it would look. Some of these are obvious, some of these have more than one way to do it. Alright, pause the video, think about that for a minute, see what you can come up with. Alright, simple random sample, there's no different way to do it. Always looks the same. You number everybody in your population. So for us, that would be students, so number all students. And it doesn't really matter how you number them. They could be alphabetically, they can be literally as they walk in the door, because we're going to randomize it after that. Okay, but then use a random number generator to choose your students. Easy enough. Systematic, I'm going to skip to that because that's also something that looks very similar. Okay, we're going to number all our students. And then we're going to do an SRS. We already talked about that. To start. Then every int student after that, however many you want in your group. So to kind of give you an idea of how this works is what you would want to do is we have, say, 900 students and we want to choose 50. We take our 900 divided by 50 and that'll kind of give us an idea of how many we would choose for n there. Okay, that would tell us how often we choose a student. Okay, now the harder ones to talk about here are stratified and cluster. Okay, so stratified, we want to think about what we're studying, and that will tell us how to group our students. So here we're talking about the number of hours per week spent studying. So we want to make sure that we're grouping them by groups that are representative, that share characteristics. So what I would do here is the easiest that I can think of is sort by grade or sort by subject. Because when we're selecting random students from each one, both of those would be representative. Okay, so we can sort by grade, sort by class, and as long as we're choosing random ones from those, then we're going to be okay. Now, one thing that I haven't mentioned yet that's pretty important and you can always say SRS here because we know what that means. But it has to be proportionally. So what that means is, I'll call it strata. If one of my groupings has 10 people and another one of my groupings has 40, so if you go by class here, like subject, and you have a class of 10 people versus a class of 40, you don't want to choose 2 students from each. You want to make sure that your sample is actually proportionate to that strata that you're choosing it from. Okay, so that's really important. Cluster. Cluster, I told you, is hard to choose a grouping that's actually representative. What I did here is sort by pride time. Because Pride time rooms have a pretty mixed assortment of those in our school. And then choose random pride times. And sample all of the students in each of those that you chose. It is difficult to choose a representative cluster, but it is something that is very convenient for those who are doing these studies to collect, because with a simple random sample, in practicality, if we think about surveying students with a random number generator, you'd have to go track down all those students to find. Whereas with a cluster, you know where all they are, you go to that pride time and you grab them. So it is something that researchers use for convenience that can be made representative if the research study is set up correctly. Okay, so you have to be careful, but it does have its benefits. If you do have any questions on the homework, make sure, as always, that you reach out to me.